It is hot outside. For fun, I'm going to add an emoji, but you don't have to. I just think it's more entertaining that way. But you do you. And I will print it. It is sunny. Sometimes these emojis are formatted differently. I'm just going to copy it from somewhere else. That's better. Currently, the temperature is 25 degrees Celsius, and it's sunny. This condition was false, but this one is true. With the AND logical operator, both conditions must be true in order for us to execute this block of code. If our temperature was 30 degrees Celsius, well then, both conditions are true. It is hot outside, and it is sunny. Let's write a few more. Let's add else if. Else if the temp is less than or equal to 0 and is sunny, we will print something else. It is cold outside. I'll change the emoji. And it is sunny. Let's set the temperature to be -5 degrees Celsius. It is cold outside, and it is sunny. Both these conditions are true, so we do this instead. You can link as many conditions together as you would like. Let's see if our temperature is within a certain range. Else if temp is less than 28, and our temp is greater than 0, and is sunny. To check to see if something is within a certain range, there is a shortcut too. PyCharm is recommending this. We can simplify chained comparisons. So this effectively does the same thing. If 28 is greater than our temp, and our temp is greater than 0, and it's sunny, then we will print it is warm outside rather than hot. And it's still sunny. So let's say our temperature is 20 degrees Celsius, and it's sunny. It is warm outside, and it is sunny. Now we have the not logical operator. It inverts the condition. We are checking to see if something is either not false or not true. So let's check to see if it's not sunny. Really, I'll just copy what we have and paste it. Else if not is sunny, then that means it's cloudy. And let's use a cloud emoji. So basically not does the opposite of what you're looking for. We are checking if not is sunny. Is sunny is false, then this condition is true. Okay, let's say our temp is 28. Is sunny is now false. It is hot outside. It is cloudy. What if our temperature was 0? It is cold outside. It is cloudy. What if the temperature was reasonable, like 20 degrees Celsius? It is warm outside. It is cloudy. So not, it inverts the condition. If it's true, it's now false. If it's false, it's now true. Alright everybody, so those are logical operators. They allow us to evaluate multiple conditions. With OR, at least one condition must be true. With AND, both conditions must be true. And not does the opposite. It inverts the condition. We check if something is not false or not true. And well everybody, those are logical operators. In Python. Hey everybody, so today I got to explain conditional expressions in Python. A conditional expression is a one-line shortcut for using an if-else statement. If you're familiar with other programming languages, this is also known as the ternary operator. It behaves similarly. Using conditional expressions, we can print or assign one of two values based on a condition. Here's the formula. Return x if our condition is true, else return y. Here's a basic example. We will create a variable for a number, just num. Let's say our number is 5. I'm going to print, then within our print statement, I will write a conditional expression following this formula. I'll just copy and paste it. Let's check to see if our number is positive. Let's print the text positive if our condition. What are we checking? Let's check to see if num is greater than 0. That means it's positive. If this condition is false, we will instead print whatever comes after else. Else, negative. Number is 5, that will print positive. If our number was negative 5, well, this condition would be false. We would instead print negative. Let's go over another. Let's check to see if our number is even or odd. Let's set num to be 6. This time I will assign the result to a variable. Our result equals, take our formula, let's assign even if our num modulus 2. Is our number divisible by 2? Does that equal 0? Else return odd. Then let's print our result. Result. Number is 6, that is even. If it's 5, then it's odd. Assign even if our number is divisible by 2. Else return odd. Let's create variables a and b. B is less than b, else return b. The minimum number between 6 and 7 is 6. This time we'll take an age. Age equals 25. We will create a variable of status equals, use our formula again, return a string of a if our condition of user role is equal to role size where we will validate some user input. As we know, a video, we will work on an exercise where we will validate some user. Ask a user, enter your full character, where we will validate some user input. As we know, a string is just a series of characters. Let's ask a user for their full name. Name equals input. Enter your full name. The first method I'll show you, well, technically this is a function. The length function will give us the length of a string. How many characters is it? We will find the length of our variable name after the user types in some input. This function returns an integer. I'll store that result within a variable. Let's just say result. Then I will print whatever the result is. Why don't you go ahead and type in your full name? The length of this string, in my example, is 8 characters. Results within a variable row. Occurrence of a character row. For me, that would be occurrence. There is a different method, which is rFind. R meaning reverse. We will find the last occurrence of an O. That has a position of 5. 0, 1, 2, 3, 4, 5. If Python isn't able to locate a given character, it will return -1. Let's find any, I don't know, q's. Python cannot find any lowercase q's. The rFind method will return -1 if there are no results. We can capitalize the first letter in a string by using the capitalize function. Name.capitalize. This method will return a string. I will reassign that to name. Then we will print our name capitalized. I'll be sure to type in my name, all lowercase. Since this is all one string, only the first letter is capitalized. Even though I'm including string, follow my name, all results. My returns type came up false. Now let's ask for a phone number. Somebody's phone number. Dot with one character with reassign this 9 zeros with spaces, dashes, or another 2, 3 phone number character. Then I will capitalize as in the data type. Here's a bunch of methods you might be interested in the future. Capitalize, casefold, center, count, encode, ends with, just to name a few. All right, everybody, here's an exercise for you. We will validate some user input. We would like a user to enter in a valid username. However, there's a couple rules. The username can be no more than 12 characters long. The username must not contain any space. And the username must not contain any digits. Let's assign a variable named username equals input. Enter
a user name. First, let's check to see if our user input is more than 12 characters long. We can do that using the length function. We will find the length of our username. The length function returns an integer. Let's check to see if the length of our username is greater than 12 characters. If it is, we'll print the message. Your username can't be more than 12 characters. Else, we will print using an F string, welcome, whatever our username variable is. Let's try it. I'll type in my first name, last name, then add a whole bunch of characters afterwards. Our users are found if I contain 2. 3. Username must not contain digits. We can use the isAlpha method of strings. The isAlpha method returns a boolean if a string only contains alphabetical characters. So let's copy that. I'll add another else if statement. Not username isAlpha. Then we will print your username can't contain numbers. I guess technically isAlpha would check for spaces too, but I'd rather have that be handled within a different if statement. All right, I'll type in a username. I'll include some digits. Your username can't contain numbers. All right, I think we've accomplished this. Let me make up a username following these 3 rules. Yep, it seems to check out. All right, everybody, and that is a few useful string methods that you may be interested in. Hey everybody, in this topic I'm going to explain string indexing. Indexing allows us to access the elements of a sequence using a set of square brackets, also known as the indexing operator. Using this set of square brackets, following a string, there are up to 3 fields that we can fill in. We can access a starting point in the string, an ending point, and a step. Here's an example. Suppose we have a credit card number. Credit number equals, and I'll just make up some number. 1234-5678-9012-3456. Good enough. If I need the first character within the string, I can type the name of my string variable, followed by the indexing operator, which is a set of square brackets. The first position has an index of 0. Computers always start with 0, so that's why the first index is 0. Then I'm going to go ahead and print this. Print credit card number at index of 0. That would be 1. If I were to change the index to be 1, 0, 1, that should be 2. Index 2 would technically be 3. Then 4 is the dash within our string, as you can see here. With the indexing operator, there's up to 3 fields that we can fill in, a start, end, and step. If you have just one field listed without any colons, it's assumed you're filling in the starting position. So now what if you would like the first 4 digits of the string? Well, we would type the name of our string variable, indexing operator. We'll need a starting index, colon, then an ending index. The first 4 digits would be 0, colon, 4. Then I will print this. And I'm just going to turn this first line into a comment. Yeah, there we go. We have the first 4 digits of our credit card number. 1, 2, 3, 4. Just so you know, with the ending index, this index is exclusive. This first number would be 0, 1, 2, 3, 4. So we did not include that dash within the number. The starting index is inclusive. The ending index is exclusive. So you can omit the 0 in the beginning. You could just say colon 4. Python assumes the starting position will be the beginning of the string. So that would work too. Let's get the next set of digits, 5, 6, 7, 8. Credit number, indexing operator. Let's find where the starting index would be. 0, 1, 2, 3, 4, 5. 5, colon, 6, 7, 8, 9. Then we will print whatever is here. The next set of digits is 5, 6, 7, 8. Maybe we need the last 12 digits. Well, what we could do in that case, we will take our string variable, credit number, set the starting index to be, let's see, 0, 1, 2, 3, 4, 5. 5, colon. If you need everything up to the end of the string, you don't need to list an ending index, just be sure to add that colon. Python then assumes you need everything up to the end of the string. So I will print whatever we have. Then we should have everything besides the first 4 digits. Yep, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6. You could also use a negative index. Credit number. If you need the last character in a string, you would set the index to be -1. Then I will print this. Print credit number at index of -1. That would be 6. -2 is 5. -3 is 4. -4 is 3. And then -5 would be that dash right here. Yeah, you can use negative indexes too. Let's talk about step. Using the step field, we can access the characters in a string by a given step. We can count by 2s, or we can count by 3s. So here's an example. So let's take our credit number. If we're not filling in the starting or ending fields, but we need a step, we would need 2 colons then. Python is assuming everything from the beginning of the string to the end of then. Our step will be 2. This will print every second character within our string. Yeah, here we are. We have 1, 3, dash, 6, 8, 9, 1, so on and so forth. If I were to change the step to 3, we would count every third character, beginning with 1, 4, 6, dash, 1, 3, 6. All right, here's a practical example. Let's create a program to get the last 4 digits of a credit card number. I'm going to assign this to a new variable. Last digits equals our credit number, indexing operator. So we need the last 4 digits. Where would the starting index begin? Well, we could use negative indexing. This last digit is -1, -2, -3, -4. We will begin at -4. Colon. We can omit the ending index. Python assumes we need the rest of the string then. Really, that's all we need. So let's print. I'll use an F string. Maybe some X's. Maybe we're hiding somebody's credit card number except the last 4 digits. Okay, then. Variable, last digits. All right, and here's our credit card number, where only the last 4 digits are visible. Hey, you know what? Let's add one more exercise. Let's reverse the characters in the string. I'm going to reassign credit number equals credit number. If we need the entire string, we don't necessarily need a starting index or an ending index. But for the step, this will be negative. -1 will reverse a string. Then let's print whatever our new credit card number is. Print credit number. And yeah, there is our credit number backwards. To reverse a string, you set the step to be -1. So yeah, everybody, that is string indexing in Python. We can access elements of a sequence using the indexing operator, which is a set of straight brackets. You can list a starting position, ending position, and even a step if you need to skip over characters. But yeah, that is string indexing in Python. Hey, everybody. In this topic, I'm going to explain format specifiers. Format specifiers, When used in the context of an F string, they allow us to format a value based on what flags are inserted. Following your value, you would type a colon and then some flags. Depending on what flags you insert, it will format your output a certain way. You could add decimal point precision, allocate space, zero pad values, left justify, right justify, center align, all sorts of things. Let's have some practice. I'll create 3 prices. Price 1, price 2, price 3. Price 1 will have some practice. Right justify, center align, all sorts of things. Let's have some practice. I'll create 3 prices. Price 1, price 2, price 3. Price 1 will be 3.14159. These values aren't in dollars and cents yet, but they will be. Price 2 will be negative 987.65. As you can see, I'm just making up numbers here. Price 3 is 12.34. Let's display our prices using some F strings. Price 1, and we will do this, is price 3. Add a colon. It will format our add dot floating point number to F. If 987 dollar signs before the placeholder. 3. Plus 2 in price addition. 4, 5, 6, 7, 8, 9, 10. Well, 0 padded. 2. Each number is now 0 padded. To left justify a value, you would use a left angle bracket. All these numbers are now left justified. Then we have all of this space after. They're all uniform. Right justify would be a right angle bracket. And I believe that's the default. Center align, I believe, is the caret symbol. Yep, our numbers are now centered. If you have any positive values, and you would like, the negative number is preceded with the negative sign. These numbers are lined up evenly, even though we have a negative number in here. There is a thousand separator, the value of our prices. 3,000, negative 9,870, 1,200. Each thousandths place is now separated with a comma. We could also have decimal point precision of 2 decimal places. Each number. Yep, here we are. So based on what you're looking for, you can add some combination of flags. So yeah, those are format specifiers, everybody. Within your placeholder, insert your value, a colon, then certain flags based on what you're looking for exactly. But yeah, those are just a few format specifiers in Python. Hey everybody, in this topic,
I'm getting
100,000 or preceded displayed after 59. These values aren't in dollars and cents yet, but they will be. Price 2 will be negative 987.65. As you can see, I'm just making up numbers here. Price 3 is 12.34. Let's display our prices using some F strings. Price 1 is placeholder price 1. Then we will do this for price 2 and price 3. Price 2 is price 2. Price 3 is price 3. Within our placeholder, following the value, we can add a colon, then some flags. Those flags are the format specifiers. They will format our value a particular way depending on what we insert after the colon. To add decimal point precision, you would type, after the colon, dot, then the amount of decimals to be displayed, maybe 2, then F meaning floating point number. Let's do that with price 2 and price 3. Colon, dot, to F. Price 1 is now 3.14. Price 2 is negative 987.65. Price 3 is 12.34. I think I'm going to add some dollar signs before the placeholder. Yeah, that's much better. For less precision, maybe one decimal place, you can change the 2 to a 1. So 0.1F. Each number only displays one decimal. 0.1, 0.6, 0.3. Whereas in 0.3F would display 3 decimal places. 0.142, 0.650, 0.340. Even though price 2 and price 3 only have 2 decimal places in the original numbers, we will concatenate some additional zeros. To allocate space to display a value, after the colon, add some number for that many spaces. How about 10? Each value now has a total of 10 spaces to display the output. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you were to precede a number with 0, well, these numbers would be 0 padded. Each number is now 0 padded. To left justify a value, you would use a left angle bracket. All these numbers are now left justified. Then we have all of the space after. They're all uniform. Right justify would be a right angle bracket. And I believe that's the default. Center align, I believe, is the caret symbol. Yep, our number space after. All these numbers are now left justified. Then we have all of the space after, which is a separator along. Yep. Insert your value. But yeah, some code while some condition remains true. Here's an example. We'll use an if statement first. We will ask a user for their name. Name equals input. Enter your name. If our name is equal to an empty string, that means the user didn't type in anything. Let's print a message. You did not enter your name. Else, we will print, using an F string, hello, our users. Hey everybody, Buddy, in this topic, I'm going to explain while loops. A while loop will execute some code while some condition remains true. Here's an example. We'll use an if statement first. We will ask a user for their name. Name equals input. Enter your name. If our name is equal to an empty string, that means the user didn't type in anything. Let's print a message. You did not enter your name. Else, we will print, using an f string, hello, our user's name. If I were to skip this prompt, we would execute this if statement, then we continue with the rest of the program. What if I would like to continually prompt the user to type in their name? We can't continue until they type in something. Well, we could replace this if statement with a while loop. While this condition is true, continue to execute this code. Within the while loop, I'm going to reprompt the user to type in a name. Then if we were to exit the while loop, then we will print hello, whatever your name is. So let's run this. Enter your name. I'm going to hit enter. You did not enter your name. Enter your name. No, no, no. Okay, I give up. I'll type in my first name, hit enter. Hello, whatever your first name is. While this condition remains true, execute this code potentially forever until this condition is no longer true. So that's one of the main benefits of a while loop. If it's not true, then you exit out of the while loop. And that's why we're able to continue, then print our name. Hello, name. You do want some way to escape out of the while loop, otherwise you'll run into what's known as an infinite loop. So let's say while name is equal to an empty string, we will print you did not enter your name. So I'm going to hit enter. So we are stuck in an infinite loop. We can't actually escape this loop. We didn't give ourselves an exit strategy. While loop, otherwise you'll run into what's known as an infinite loop. So let's say while name is equal to an empty string, we will print you did not enter your name. So I'm going to hit enter. So we are stuck in an infinite loop. We can't actually escape this loop. We didn't give ourselves an exit strategy. That's why previously we reprompted the user to type in something. We're giving them a chance to escape. In a way, it kind of works like an if statement, but instead of executing some code once, it's potentially infinite. Here's another example. This time, let's ask for a user's age. Age equals, and I will convert the input to an integer. Enter your age. We'll need the user to type in a positive number. While age is less than 0, let's print a message to let the user know that they can't do that. Age can't be negative. Then we need some strategy to escape. Let's reprompt the user to enter in their age. Once they type in something that's valid, we can escape out of the while loop. So let's print, using an f string, you are age years old. So enter your age. I'm going to say -1. Age can't be negative. -2. -1 million. Okay, I give up. How about 21? You are 21 years old. So that was another example. While our age variable is less than 0, Repeat this code forever. Let's go over example 3. I'm going to introduce some logical operators. We will have the user type in a food they like. Food equals input, enter a food you like. But in order to escape, they need to press Q to quit. While food is equal to the letter Q, continue this while loop. However, I'm going to make one change. We want to exit the while loop when they press Q. So you could say while not food equals Q. So within this while loop, let's print the food that they stated that they like. I'll use an F string. You like your variable food. Then we will prompt the user to enter in another food that they like. Enter another food you like, Q to quit. Then once we escape the while loop, we will print just buy. Okay, enter a food you like, Q to quit. I like pizza. You like pizza. I like sushi. You like sushi. I like ramen. You like ramen. Okay, this program's kind of lame, so I'm going to press Q to quit, and we escape the while loop. We have printed buy. So you could do something while something is not true by using the not logical operator. All right, last example, example 4. We will use the OR logical operator. We'll ask a user to type in a number between 1 and 10. Let's say num equals input. Enter a number between 1 through 10. Then I will typecast the input as an integer. While our number is less than 1, or our number is greater than 10, let's reprompt the user. Let's print, using an F string, our variable num is not valid. Then we will reprompt the user. Enter a number between 1 and 10. Once we escape the while loop, then we will print our number. Using an F string, your number is our variable num. Enter a number between 1 through 10. 0. 0 is not valid. -1. 100. Nope. 5. Your number is 5. That's an example of how you can add logical operators to while loops. While this condition is true, or this condition is true, execute this code forever. All right, everybody, so those are while loops. A while loop will execute some code while some condition remains true. It's fairly useful for verifying user input. If a user types in some input that is not valid, you can reprompt them. And there's many other uses that we'll discuss in the future. But yeah, those are while loops in Python. Why, hello everybody. In today's video, we'll be creating a compound interest calculator in Python. For those that don't know, interest is a charge for the privilege of borrowing money to some individual or organization. When you place money in a bank account, you typically accrue interest. We'll create a program to tell you what your new balance will be after accruing interest for so many years. But the user is going to decide the initial principal, that's the investment, the rate of interest, and the time in years that this balance has been accruing interest. So let's begin. Let's declare 3 variables: a principal, a rate, that is rate of interest, and time. Time will be in years. We've recently learned about while loops. I would like to include those within this program, just so we get the hang of using them. We will ask the user to type in an initial principal investment. We will continue to prompt the user to type in a principal that's above 0. Our condition will be while principal is less than or equal to 0. We will take our principal, assign it some user input. Enter the principal amount. Then we would like to typecast our input as a floating point number. If our user input, principal, is less than or equal to 0, we need to inform the user. While principal is less than or equal to 0, we will take our principal, assign it some user input. Enter the principal amount. Then we would like to typecast our input as a floating point number. If our user input principal is less than or equal to 0, we need to inform the user. Principal can't be less than or equal to 0. So I'm going to test my program by printing. Then we would like to typecast our input as a float. Zero. We will take our principal, assign it some user input, enter the principal amount. Then we would like to typecast our input as a floating point number. If our user input principal is less than or equal to 0, we need to inform the user. Principal can't be less than or equal to 0. So I'm going to test my program by printing the principal at the end just temporarily. Enter the principal amount. I can't type a negative number and continue. What if my investment was negative $1,000? Principal can't be less than or equal to 0. How about 0? Nope, can't do that either. Is 1,000 okay? Yep, 1,000 works. That is for the principal. Let's copy this while loop, paste it, replace principal with rate. This is the rate of interest. Enter the interest rate. Interest rate can't be less than or equal to 0. Then let's copy this again, paste it, change rate to time. Let's typecast our input as an integer because we're working with whole years. Enter the time in years. Time can't be less than or equal to 0. I'm going to print my principal, rate, and time. We have principal, rate, time. Okay, we know that principal works. Enter the interest rate. Can my interest rate be -1? No, it can't. Can it be 0? Nope. How about 10%? All right, that works. Time, can time be 0? No, it can't. Can my time be -1? No, it can't. What about 3 years? All right, so we know that our while loops are working. Now here's the formula to calculate interest. Let's say our total, that's our total balance, equals our principal times 1 plus our rate divided by 100. I'm going to enclose this function with a set of parentheses. This portion of our function will take our interest rate, which is a whole number, then create a decimal. Enclose this function within the power function. Raise this function to the power of time. And that is how to calculate compound interest. Then we will print the new balance. I'll use an F string. Balance after our variable time, the word years. I'll add a placeholder. We will add our total. Then I'll include a $sign. Maybe this will be in dollars, but pick any unit of currency you would like. I will format this variable with the format specifier. We will display 2 decimal places, point to F. Okay, let's try this. Enter the principal amount. I invest $1,000 into maybe the stock market. The interest rate is maybe 10% this year. The time in years will be 1. So after 1 year at 10% interest, my new balance is $1,100. Let's try it one more time for good measure. Maybe $500 with an interest rate of 7. over 2 years, your new balance would be $572.45. All right, now there is another way of writing this program. What if we would like to allow the user to enter in values that are equal to 0, while principal is less than 0? If principal is less than 0, principal can't be less than 0. Let's do that for rate. Interest can't be less than 0. Time can't be less than 0. Here's what happens to our program. Remember that we're declaring our variables at the top. Nothing happens. We go straight to the results. So the reason that this is happening is that when we reach the while loops, this condition is false from the beginning. We never end up entering these while loops. We skip over them because these three conditions are all false. We can write a different variation of this while loop where we could say while true is a Boolean. That means this while loop will continue forever unless we explicitly break out of the while loop. We're going to add an else clause. Else, we will break. Break will break out of a loop. With our second while loop, change rate is less than 0 to while true. Then we will add an else clause. True. Principal amount dollars, 0 values. $1,000. Well, okay, you could write either a standard while loop with, or you could say while true loop. Hey everybody, in this topic, we're in Python. Hey everybody, in this topic, I need to explain for loops. A for loop will execute a block of code a fixed number of times. You can iterate over a range, a string, a sequence, anything that is considered iterable. I'll have more examples for you in future topics. There is a lot of overlap where you could use either a while loop or a for loop, but for loops tend to be better in situations where you have to do something only a fixed number of times. Here's an example. Suppose we need to count to 10. If we were to use a for loop, we could write something like this. Then we would need some sort of counter. Typically, you see people write x. For x in, then we will use the range function. What number would we like to start at? I would like to start at 1, then count to 10. But the second number is exclusive, so really we're going to write 11 if we want to count to 10. So then colon, then hit enter. Whatever code you would like to repeat a certain number of times, you will list underneath the for loop and make sure the code is indented too. I will print whatever our counter x is. When I run this code, we will begin at 1, then stop once we reach 11. So yeah, there we are. We have begun at 1, and we have counted all the way to 10. So that's the basic syntax for a for loop. For, some counter. Really, you can name this anything. Sometimes you'll see people name this as counter, and that would work too. But let's stick with x. In some range, where would we like to begin? Where do we stop? Okay, now let's count backwards. Let's start at 10, then count down to 0. When we escape the for loop, let's print Happy New Year. When we print Happy New Year, we are outside of the for loop. To count backwards, you can enclose your range function within the reversed function. Reversed. So we begin at 10, count down to 1, then print Happy New Year in this case. To count backwards, you would enclose the range function within the reversed function. There is an additional parameter too you could add. That is the step. If you would like to count by 2s, you would add comma 2. So I'm going to get rid of